I can't see the chat window or anything, so I'm assuming.
Yeah, we're good.
Good.
Start.
Okay. All right. So thanks everybody for coming to our February meeting. We actually got two this month. Al Rodriguez is going to talk to us today about CRUDing your cloud with C# and Pulumi, or I'm not really sure. But he's going to tell us all about it and tell me how I got it wrong. So this meeting is being recorded. Thanks to Tim, who started the record. So just be aware, you know. So we ask that you mute when you're not talking or asking questions. Consider turning off your camera once once we're done with this opening text for the presentation. There will be a time at the end to ask questions, but we can leave it up to the speaker as far as when to take questions during the presentation. We do have a raise hand feature. You know, if there's a pressing one, or you're not really sure about something, and we may ask you to come off mute and ask your question, or you can use the chat window. So this is the welcome and announcements portion. As a reminder, today's talk is being recorded, and it will be available on YouTube shortly after this is over. Al is, like I said, talking about CRUD your cloud with C# and Pulumi, I'm guessing, which I probably should have checked beforehand, so that's on me. How do you CRUD your cloud? A lot of YAML, Terraform, Bash scripts. So yes, we don't want Bash scripts that everybody's too scared to modify. Manually clicking around the portal UI, embedding is a mix of different technologies. No one has the time to fully learn. So we're going to talk about that and CRUD, cloud infrastructure services. You probably read all this in the meetup, but we're using C# in this presentation. Here's our OneTug board. Santosh is well, we've kind of we all contribute, but Santosh is sort of our leader, and myself, Andy Leck, Tim Lentine, who's on this call, Todd, who's unavailable, Tanner, I'm not sure if you're on, and Brian Mischler is our member at large. We have a bunch of ways to get a hold of us. Links on the onetug.net to the different social media, or if you want to contact us by email, it's board@onetug.net. And then 2 weeks from today in the morning, so AM, which is not our usual Eastern time, Purnima Nayar, I believe, is going to be talking about REST, GraphQL, and gRPC, and a comparison between each of those. So if you're you want to go between APIs and more operational sort of things, or you want the large, you want to be a social networking infrastructure of the GraphQL and have it targeted to a bunch of different users, that's going to be the talk for you. Monthly sponsor, we're always looking to have a monthly sponsor. And if you do want to sponsor, get a hold of us at board@onetug.net. This time we like to, ask anybody who's got a community announcement to raise your hand or come off the microphone, and so something particularly open source project, another meetup, another something you're working on at work to share, .NET related. So if there's anything like that, now's the time to speak up. Okay. So I'm going to continue. Al has been a programmer focusing on .NET development for over a decade. He's worked on a wide range of applications in that time, like a website you haven't heard of, a website you have heard of, and a website you've seen but forgot about. I think at least one of those I've worked at the same place at different times as him, but most people in Orlando have, but I'll check with him later. If you like bad jokes, you can follow him on Twitter at ProgrammerAl. That's Al, A-L capital, not A-I, as he's pointed out he gets confused for, although it's not a bad thing to be confused for. If you like good jokes, follow Sarah CPR. Al is no association with her. Sarah is just really funny. Okay. So with that, I will turn it over to Al, and as soon as I stop sharing.
All right, cool. So as soon as I find the share content button, here we go. It tells me it's presenting. So I'm just going to go ahead and assume you can all see my screen, and I will start talking now. All right, everyone. Hey, welcome. You've already seen the this title a few times already. Coding your cloud with C# and Pulumi. I think Pulumi is how I pronounce it. I don't think the pronunciation really matters at all. But the important thing is Pulumi. That's the thing that we're going to spend a lot more time really talking about today. We just happen to be using it with C#, which is one of the cool benefits. Before we jump too far into it, just a couple things about me. You've already seen my bio and all that stuff. But if you just want to find me in things like Twitter, LinkedIn, GitHub, etc., just search Programmer Al. You'll find that. A couple other things about me. I co-organized the Orlando IoT meetup. So we've been on a good streak recently about having meetups because we tend to take a few months off in between here and there. So we just had one last night. We're going to have another meetup next month, actually talking about Azure Digital Twin. So if you're interested in Azure's service for smart buildings, we'll be going over that.
Hey, Al,
and then,
is this online meetups or in person?
Yes, yeah, we're still virtual only. So
okay,
yep. Yeah, cool, good, but good question. And then lastly, I am not affiliated with Pulumi at all, but they did send me this free shirt when I told them that I was going to be doing this talk. So that's all they paid me to do. All right. And then before we really start talking about the stuff, I put everything already online on my GitHub repo. So if you just go to github.com and, well, that link right there, presentations-2022, I try to put all my presentations, all my talks per year to one repo. This is the only one so far. And hey, maybe it'll be the only one for the year. We'll see what happens. But if you want to download the sample code, all of the code that I'll be showing off as examples today, that's already up there. So let's start with a quick story on how I went from the knowing nothing to actually knowing Pulumi. A couple of years ago, I had an idea for a side project. There's a little bit of a story on how we got there, but that's for another time when I have more time to talk about it. The idea was I wanted to create a couple of services in Azure, and there was going to be one Azure function and one queue. And so the function was just going to read off of the queue for some messages for some processing. Now, normally I would just go to the portal, click the button, say, all right, let me create the function, let me create the queue, and that's it. But for this project specifically, I also wanted this to be not just in one spot, but I wanted it in some number of regions around the world within Azure, right? So I don't know, 10, 15, 20, there's a ton of regions, just a bunch of them. So at that point, that's something you automate. Even if it's a thing that you're just setting up the one time, it's a hassle, right? You might mess it up, and then you have to start copy pasting all these kinds of connection strings all over the place. No one wants to do that. So I started looking into what were my options for automating this. At the time, because I knew I was just staying within Azure, I could have just gone with Azure ARM templates. But those have some pros and cons. I think working with some of those templates are a lot of cons. And at the time, Azure Bicep didn't exist yet. I haven't worked with that yet, but you know, again, pros and cons with that solution, but also purely Azure. Next, moving on, I knew of Terraform by HashiCorp. From what I know, it's essentially it's kind of the de facto choice, right? You go to some company, you say, hey, how do you automate creating resources in Azure, AWS, or whatever, right? By default, most companies use Terraform because it's been around a very long time. It has a lot of documentation. It's a solid product. There's a lot that's good for it. So I went to their website, started looking around, just started, I wanted to familiarize myself with it. And the downside was that there was a lot that you have to learn to really get started, right? That learning curve is steep, and then you're pretty effective. So I thought, okay, well, that's something I could use, but I had already heard of Pulumi. So let me go ahead and look into this product. Let me see if maybe it's better in some way. And I really liked it. Part of the reason for that is that there was less that I had to learn immediately, and that was part of what drew me to this. So Pulumi is a competitor product to Terraform, if you want to think of it that way. Works with just about every cloud that exists, and so the number one feature that I like of Pulumi is that you can use your choice of programming language. Now, there's only a handful of languages, but it's not all of the programming languages. But I got to use my choice of language, which is C#. Unfortunately, at the time, C# didn't exist, so I used TypeScript. But I still got to use my choice of programming language in the tooling that I'm used to using. So nowadays, and all of the examples that we're about to look at are all in C# through Visual Studio. If you wanted to use C# in Visual Studio for Mac or Writer or something else, go for it. That's your choice. And so that's how I got to where we are today. So now I should probably tell you what Pulumi actually is. You probably already figured out the basics, considering I've already compared it to Terraform, but it's a tool for managing your cloud infrastructure. If you want to think of it as infrastructure as code or desired state configuration or any of those other acronyms that may or may not exist, because I listed the only two that I know of. I don't know if more exists for this kind of thing, but it's a tool for managing that stuff. Now it works with all of the major cloud providers, and then there is support for a lot of the lesser known ones. For example, Cloudflare, that's one that I've personally used a few times. Akamai, stuff like that. We'll go through a list a little bit later. And lastly, it is the tool itself is open source. Now it is made by a for-profit company. They make their money with some services that you can use for essentially for keeping track of the state of your cloud infrastructure. As a company, it's probably for anyone, it's probably just easier to pay them for that instead of going the free route of doing a lot of self-hosting. All of the examples that I'm going to be showing you today are using their paid product. However, they have a very generous free tier. I have never paid them a cent. So for me, so far, they're in the negative because they've sent me this shirt. And really quickly, I just want to say what Pulumi is not. If you've never worked with something, a tool like this, it's very easy to think that it's some kind of higher level abstraction above cloud resources. And that's something that I thought that this was too at the beginning before I had really before I really jumped into working with these kinds of tools. So it's not something where you can say, hey, I want some sort of storage account and something for compute and a database, and I want that in Azure and also AWS. It's not some higher level thing. You are still programming directly to that cloud. So you would have to say, I want in Azure, I want a storage account and a blob storage container. And then in AWS, I want an S3 bucket, and etc. for the other clouds. I'm only going to be talking about Azure for this talk for two reasons. One, I assume that that's probably what the majority of people here know. And then separately, it's the only one I really know. So I just don't want to talk about the thing that I don't know very well. All right, cool. So you probably have a couple of questions of things that I've already alluded to, like what programming languages does it work with? So this image that I took directly from their website shows all of the programming languages that you can use today working with Pulumi. So again, we're going to be doing everything with C#, but if you want to play around with creating everything through Python or Go or F#, hey, feel free. They're right there. And let's go ahead and look at this list of the on their registry. So let me move that because that opened in a different window. But this page right here is showing everything that you can go ahead and use that you have some form of support using Pulumi. Now, some of these are first-party packages, some are third-party, so it's something to keep in mind. The featured ones up here are the ones that Pulumi, the company, creates. And then as we scroll down below, you can kind of see a lot of other ones. So like I mentioned, Akamai, I think I mentioned that before. If you've ever worked with Auth0, right, you can start to see kind of a lot of these different things. So definitely feel free to scroll through and see, what are things that already have support if you're maybe, on the fence on which thing to use or not to use. Cool. Oh, and really quickly, I do kind of keep going back and forth on saying Pulumi the tool and Pulumi the company. This is unfortunately like a Google situation, right, where the product, their main product, is also the name of the company. Unless I say otherwise, I am talking about Pulumi the tool. So, all right, now let's go ahead and jump back into the slides. And I should probably here. All right, so let's run through a quick demo. That was very ill-timed because I just brought that up right to share this. So I have my command prompt up here, and because Pulumi installed on my machine is a command line utility. So I'm just going to go ahead and run this Pulumi help. Ooh, oops. All right. So there's quite a few options. I'm not going to go through and talk about each one of these, but I just wanted to show you that it is a command line utility, and I'm already in an example folder. So let's just so you can see this, I'm going to go ahead and create an entirely new project. So Pulumi new, and it's going to go ahead and give me some options. Now, like I said, I really only know Azure and C#. Those are the only ones I know well. I know very little about the other combinations of things. So let's go ahead and hit enter. Let's see, project name, I'll hit enter to use that default. Description, I'll hit enter to use the default. And stack name, we will go with dev. So we'll talk about stacks a little bit later, but just go ahead and think of them as an environment. So the dev environment, QA environment, production, et cetera, et cetera. So this has gone and created that. And let's go ahead and open up the folder that this was created in, just so you can kind of see what it creates. Now it created it created this whole solution right here, exactly like you would assume a normal .NET project would be created. So if we look at the actual project, notice this is .NET Core 3.1. Nullable references are enabled, which is great. I love that. And then over here we have two C# files. So first off is program, which they don't really need because they can. I think they should just throw this into stack. This program CS file only exists to run the mystack CS file, and then this file, the mystack, this is what you're creating and the resources that you're actually creating when you run this. Now I'm going to go ahead and close this because we already have another solution with some example code, and this is the one that we'll be talking about for some examples. So, I had already mentioned that, hey, this is just like any other C# application. So I went and I started making some of the changes that I personally like to do with the C# stuff that I do, right? I want to use the latest and greatest .NET framework. Same with the latest language. I also personally like enabling nullable references and treating all warnings as errors. So I have the compiler telling me that, hey, something's null and you didn't do anything about it. But also, all of my references for everything Pulumi related are all NuGet references. So it's just set up right there. So again, this is just like any normal C# .NET project that you would work with. All right, and then let's actually talk about the stack. So we have a couple of things here, and I'm not going to jump too far into the code because we are going to jump back and forth. But just so you know kind of the outline, first off, we're loading values from config. Then we're going to go ahead and create a resource group. And then we're creating two separate types of resources. Now, this create storage account I have commented out because I wanted to show an example of, oh no, what? I am not able to type. Oh, you know what? This has happened to me before with Visual Studio, and I just restarted. So I don't know what happened there.
Hey, Al, while you're doing that, question in the chat.
Oh, yeah.
Do they support building services and configuration on-prem besides cloud?
No, they are a cloud-only tool. So well, sorry, let me rephrase that. So they are a cloud-only tool. However, if by on-prem you mean something like Kubernetes, that is an option. So if we go back to the registry up here, Kubernetes is one of the things that they work with. Now I know nothing about Kubernetes, so I'm gonna try to say very little. But my assumption is that, I mean, Kubernetes is basically its own cloud, like its own whole setup and everything. And I've made it this far not learning anything about it. I'm really hoping to make it all the way without having to learn anything about Kubernetes specifically. But that is probably the closest that you can get. There are some other things, some other resources. Let's see, command line. Yeah, so there's, like, if you want to run things as a command line, there are some benefits that you can get out of this tool if you are running only on-prem. But it's going to be few and far between. And essentially the only benefit you'll get out of that is keeping track of your resources. And we'll talk about how Pulumi keeps track of resources a little bit later, but I really don't think that you'll gain any benefits if you try to run this on anything on-prem. All right, cool. So now, all right, now I can I can type. I have no idea why Visual Studio does that. Might be an extension I have installed. So now let me open up this other command prompt window that I have up, and I'm going to go ahead and run Pulumi up. So this Pulumi up command is what you run when you want to run Pulumi. So I've already run this solution earlier, but you just saw me uncomment some code. So now it's going to go ahead and say, hey, we have this storage account. We're going to go ahead and create it. So do you want to do this? Yes. So now this is running, and we'll let that run for a minute, but I will show you what already exists. So this resource group right here is what was created. Sorry, can someone?
Hey,
okay.
So yeah, please mute your microphones, and if you don't need to be on video, then please turn that off.
All right, cool. Looks like we're good now. All right, so this resource group right here is the one that was created. Now we'll talk about this naming convention a little bit later. I told it to make one called example RG, but it added this extra set of characters at the end. We'll talk about that one a little bit later, but we'll go ahead and click on this. And this has my services. And let's see, looks like this is the storage was created. You know, sometimes I just have to hit F5 to refresh. I don't know why that refresh button on here doesn't always, but yeah, there we go. So now all of my Azure resources are created. So we have an app service, an app service plan, and a storage account. So everything that I've told Pulumi to create in Azure is created there, which is great. Now, I'm going to go ahead and go to this page. So this is Pulumi's website. This is keeping track of the resources. And so this presentation's 2022 one-tug example. This is the project that I've created. So Pulumi separates everything based on top level is projects, and every project has a number of stacks. So let's click on the dev stack. And we can kind of see just a few pieces of information about what we've created. So there are some outputs. We'll talk about what those mean later, but it's things to keep track of. Just, you know, some results of actually making your resources. Here's all of the config that I've created. It's actually in a file, but it was also pushed up to Pulumi to keep track of. We have the activity tab, so you can see when I was experimenting and running this earlier. And lastly, something that's really cool is the resources view. So this shows you all of the resources that Pulumi knows about that it has created. So there's two views. You have a list view or a graph view, which is, I think it's pretty cool, even though it's not like super useful, I guess, because you have the one, you have, you know, your stack and then just links to everything. It's always going to look like that. So, you know, I'm not sure how useful it is, but I think it looks cool. And then if I want to click on any of these, like the web app that we created, we can see all of the settings for this application. You know, the default host name, you know, all of this kind of, all of this stuff, everything that is a setting for that resource in Azure. All right, and that's it for the demo really quickly. Any questions before we move on?
Yeah,
Let's
Dave
see.
has a question in chat.
Yeah, so the question, I might be getting ahead of myself, but are these Pulumi routines idempotent, i.e. you can safely run them multiple times without duplicating the created resources each time, or is there a way to make it work that way? Yes, by default, it is idempotent. So if you run it 100 times, it will only make those resources if they don't already exist. Or if you make a change to something, like you make a config change or code change, it will change just those parts of the resources that it needs to. Unless it knows that it has to completely recreate it, then it does some stuff to delete what already exists, create the new thing, but it does it in a way so that there's no downtime. There's a way that it does it. Essentially, make the new thing, transfer over some values, and then delete the old thing. So, but yes, by default, completely idempotent. That's the goal. And actually, that is the next thing that we are talking about. Kind of go more in depth with that. So I don't see any other questions in the chat. So I'm going to go back.
So I have
sorry.
a question. What do you do for configuration? Like, there are different types of configuration. Like you have name, you have secrets and values. So how do you handle all of this?
So there is something built into Pulumi. We do have a couple of slides later on that talk about that specifically. So I don't want to go into it too much right now. But you can essentially there's a config file. It's YAML. I'm sorry, but I think YAML for just config is fine. I'm good working with it at that level. But yeah, we'll talk about that one a little bit more in depth later because we have some code examples and stuff like that to show. All right. Any other questions before we jump back into the slides? All right. I'll take the silence to mean no questions. All right. So this image right here, again, another one that I pulled off of their website, is a pretty good write-up of how Pulumi works and the stages that everything goes. So let's see, is it this button? Nope, sorry, wrong button. Oh, great, press the wrong button. All right, there we go. So your code or our code, anything that we write, well, it's this. But remember how any code that you write, or sorry, any code you write in your choice of language that's supported, it all needs to go to the same thing, right? So your code essentially calls into something else, into this language host. Now, when that creates something, that goes to the actual, the important part, the underlying Pulumi tooling. And I don't know exactly how this works. My assumption is that you're essentially calling into some method, and then that method calls into something, some underlying piece of infrastructure, probably this thing right here, this CLI and engine. Now that is written in Go. So there's basically just a whole binding layer in between, which I assume is what language host means. It's the binding layer, so that way your code can talk directly to this Go stuff. And then that Go stuff then figures out what to create or delete or to modify. Create, read, update, delete. Yeah, all the normal CRUD stuff. So when it does that, it needs to compare what currently exists to what you want to create. So there's essentially two steps, right? There's step one of, okay, let's figure out what's the stuff that you need to make first. Now let's compare that to what existed before in the back end. Now, Pulumi calls this the back end. And remember earlier when I was talking about Pulumi hosting some services for you, or you can self-host? Essentially, the backend is what I was talking about. You can supply your own database for keeping track of this stuff, or you can, again, use Pulumi services for doing that. So once Pulumi has figured out the changes of what it needs to do, then it goes and runs all that in whatever cloud provider it is that you're running this in. So that's the general idea, right? So you have your code that runs. It talks to some other process written in Go. That process is the thing that really figures out what changes need to happen based off of what you want now and what you already have. And then it sends commands off to whatever it needs to send those commands off to do. All right. So let's talk a little bit more about that backend, about that state. So we've kind of already talked about a lot of this stuff that we have on here on this slide. But the backend is what keeps track of the current state of the of your infrastructure as far as what Pulumi is allowed to know about. It takes things called inputs, it creates outputs. We'll talk a lot more about inputs and outputs in a second. And it keeps track of any secrets and config values. So all of that goes into your backend. Like I mentioned, you can either use their hosted SaaS tool or you can self-host it yourself, however you want to work with that. And this state is importable or exportable. So if you need to tell Pulumi, hey, I've gone and I've added this other stuff manually. Let's go ahead and add that in. So if you ever have any kind of drift or something to that effect, there is something built in to tell Pulumi to know about it. Now, depending on what you've done, you might have to make some code changes or something to that effect. Maybe you've gone into the portal and like Azure Portal, you changed the setting by clicking a button, and then you changed your code, your config, to use that same new value, but the backend state doesn't know it. And so anytime you try to run this, it could error out. So you can run a command to tell Pulumi up the backend to just refresh yourself. Go query the cloud provider, go query Azure, find out what's changed, because that is going to be the source of truth right now, instead of you, the backend. So that's the idea behind that. All right. Now I said we're going to talk a lot more about inputs and output objects. So the time has come. Now, the concept sounds simple, and really it is, but this is kind of the number one thing that is probably the most difficult to wrap your mind around. The idea is when you want to create a new resource, you pass in an input value. Hey, I want to create a resource group named my resource group. But that's just what you're requesting. That's what you want to create. Now, the outputs are something different. Now, remember earlier when I showed off the resource group and I said it's a example-rg, but Pulumi created this kind of cryptic looking extra characters added to the end of the string. That's because how it manages it, it knows that it's not always able to just use the value that you created. So for example, if it needs to delete the current resource group to create a new one, for those rare occasions where that's just how that works, that's how it does it, because it needs to create a new resource group with all of these other properties, basically with the similar name, right? So it's going to make this new one with this added cryptid characters at the end of the name. And then once this new one works, it's going to delete the old one. So that's how that works. I've never been in that situation with the stuff that I've done for having to essentially delete the old stuff and make the new thing. But it happens, right? This is just one of those things that there are limitations sometimes, and that's just how that works. So the idea behind an output is this is the value of this thing after it has been created. So you don't always know what that value is until it's created. One good example is, we saw earlier that I created an Azure app service. You don't always know what the default host name is, right? Like sometimes it'll just give you something random. I've spent more time with Azure Functions, and that is definitely a random name, essentially, that it gives you, right? I think you might be able to request a default host name. I'm not too sure, but let's say you want to then reference this value. That's something where outputs come into play a lot. So let's look at a code example. So now that I've kind of talked about this a lot, let me show you really what I mean. So back to the code that we have over here, and let's talk about this app service. So let me go down to this code and make that a little bit bigger. So like I said, with something like Pulumi, whenever you're creating resources, it's just like if you were using some other tool like Azure ARM templates. If you were going through and clicking the web portal and you want to create a new app service, anything that you would do there, you're doing here in code, and that's the idea. So for an app service, you need an app service plan and then the actual app service itself, which in this case is called the web app. So the common pattern for this is two input parameters. There could be more, but generally you're only going to write the two input parameters. The first is the name. What is the name of this resource within Pulumi? And then what are all of the arguments? So just notice that this input object is for the app service plan. We're passing an app service plan args. Similar to down here for the web app, we're passing web app args. So it's just input arguments specific for this service that we want to create. Now, for the args, I want you to notice that all of the let's see. Let me go to the definition. All of the inputs all of the parameters are input objects. This is an input of type string, input of type bool, input of type bool. But when we actually want to use this app service plan after it's created, notice that all of its properties are outputs. So ID is an output. Free offer expiration time is an output. And I can just start scrolling through, right? These are all outputs because we don't always or usually know the values of these until after the resource is created. So I want you to notice something down here that I've done is server farm ID is equal to appserviceplan.id, right? We need to link this plan to this app service plan itself. Or sorry, we need to link the web app to the app service plan. And so that's where things start to matter as far as Pulumi goes. So when Pulumi is actually creating all of these resources, it's trying to do all of them at once, right? It wants to say, hey, let's create everything. Let's send all of these commands. But now I know that before creating this web app, I have a dependency on that service plan existing. And so using these inputs and outputs is something to tell Pulumi or to help it know what's the order in which to create things. Because if something doesn't have a dependency on it, or if something doesn't have a dependency on something else, it's going to go ahead and just create it immediately as soon as it can. And so that's the idea behind inputs and outputs. So any questions on that concept right now?
Yeah, sorry, I'm still, I don't understand where the dependency comes from. Does it come from the fact that you used app service plan as input variable into the web app, or did you?
Yeah, so the idea is, right up here, we're creating an app service plan, right? And so within Azure, right, you have, if you want to go ahead and create some kind of Azure app service, you need two things, right? You need the app service plan, and then which is essentially the virtual machine that you're running on, and then the app service itself, right? In this case, they call it a web app. That's the name. I assume that's, I think a lot of these names are just things that were auto-generated based off of something that they have. So that's where web app comes from. But the app service itself that's the thing that's actually running on the virtual machine, right? So Pulumi has to know, or in real life, if you were to go and create these things, these have to be created at two separate times, right? The app service plan has to be created first, even if you're using some other tool that'll make them both together. That tool is still doing them in this order, right? If you go to the web portal right now and you try to create an app service, or it'll ask you about the plan. Do you want to use one that already exists, or do you want to create a new one? And then if you want to create a new one, it'll ask you for some settings. And then when you actually go and finally click that button at the end to create everything, it'll make the plan and then the app service. Now, in this scenario, because we have an app service plan, down here, we need to link this new web app to the plan itself, right? So we need to say, hey, this app is running on essentially this virtual machine, this thing that's actually going to be hosting the application. And so this is the setting that actually does the linking. Now, because this value right here, because this property ID is an output, that's essentially what Pulumi looks at to know that there is some sort of dependency on this. And so what we're saying is, okay, well, this property, we can't actually set this property until this property exists. So we need to go and create this object, which is the app service plan. So it's just it's setting those dependencies. So like I said, this can be a little confusing. Once you work through it, It gets easier. It took me a while to really understand it. I don't know if I answered your question well for anyone else.
The reason I'm asking is, in ARM templates, like you have the depends on word that you use to say that this, so it's kind of explicit. Like it actually says that, it depends on, instead of me simply passing in an ID and expecting it to behave that. But it seems like Pulumi is doing that behind the scenes.
Mhm. Yeah, exactly. Yeah, so it's not an explicit thing. In a sense, it's sort of kind of explicit because your code is linking that, but it's a little hidden, right? It's right here we are explicitly saying use an output property of a different resource, but we're not saying explicitly, okay, this is a dependency. Like you kind of just have to know that that's how that works. That's how that's set up within this tool. Mm-hmm. All right, cool. Let's see. Any questions around inputs and outputs? Okay. All right. So those are the basics behind that. Now we've kind of already talked about this a little bit, but actually using or setting the values for outputs. So I've kind of mentioned that an output is a value that doesn't exist until the resource is created. That's the idea behind it. So what if you want to use that for something like string interpolation, right? Which is exactly what's going on right here in these two code examples. So that's where this .apply or sometimes output.format methods work. The idea is we want to set some variable to something based off of this output, but we can't actually set that value until this thing is created. Because again, while this is C# code that we're writing and it runs line by line, it's calling into something else that's actually doing its own, keeping track of the state of things that it's creating, and it's not guaranteed that it's going to run in order. You may type all of your code as instruction 1, instruction 2, instruction 3, but that's not how creating cloud resources works. So that's why this again can get a little confusing. So if you want to do string interpolation, if you already have an output variable, like DNS name right here is an output string variable, then you can call the .apply method and then just return whatever the string is. You can also do the same thing. In this case, the assumption is that hostname and port are output strings, and this will create an output string, a single output string based off of those two values. Or if you just already have a value, you just want to set something else, you can go ahead and do that. So again, this is just how you would get that value for, again, it's all just dependencies. That's how it comes down. Yep. All right, and then the next one is, and this is kind of the last thing we'll really talk about outputs, is custom outputs. So the idea of a custom output is, this is an extra thing that I want to keep track of for later access. And this can be literally anything. So we've already seen the results of some of these custom outputs. And let me actually go ahead and bring that back up over here. So, so again, this is Pulumi's website of the stack that we ran earlier. Now, all of these properties, everything that we're seeing right here, these are regular outputs. These are the values that we have already set for our web app, right? Because this is the, so this is the web app. So availability state, if I go back to my code and I look at web app, I assume that there is a availability state property. Yep, there is, right? So so all of the outputs, if I go to the definition, great, it has to take a second, but all of the properties of this object are outputs. And so every single one of these is something that has to be kept track of. So server farm ID, there we go. So if we go back up here and I search for server farm ID, this is the ID of that app service plan resource that we were talking about earlier. And I assume if I click on this link, I've never done this before. If I click on it, does it go anywhere? Oh no! Oh no! It just goes to the app service plan itself. Okay, well that's also pretty good. I was hoping maybe it would go to the Azure portal, but this works. I like it. Now, those are essentially built-in outputs, right? Things that you are already using because these are already objects that Pulumi, the tool, has access to. But notice this line 65 that I have down here, I'm setting something to default host names. Let me go to the definition, and I have created some outputs. So I see these primary storage key, web app endpoint, and random password. So I've set random password as an output. We'll talk about that one a little bit later because there's a couple of things to know with it. But basically what I'm saying is that these are 3 extra things that I want to keep track of. And if I were to go back to the portal right here and I navigate back to my stack, notice that those 3 properties are set right here. So web app endpoint is this random value that I mean, I don't care about it, right? We shouldn't care about what the value is because we have our tooling keep track of that. And something you can do later is read that value and store it in wherever file it is you use to start linking endpoints, right? And then notice that my random password and this storage account key are locked. It's not something that I can view here because the value is encrypted. I have done something to mark those as a secret, so Pulumi doesn't show it here. It keeps track of it. We'll talk about that one a little bit from now. But going back here, so this web app endpoint is like we're just setting that to an output. So that just gets set. Cool. Any questions on outputs or inputs or anything like that? All right. I don't see anything in the chat, so I'm going to go ahead and move on.
There's a hand up.
Sorry, I did not see that. Yeah, if there's a hand up, what's your question?
Yeah, please come off mute and ask your question, or type it in chat.
Okay, I'm not seeing anything, so I am gonna move on. But if you type the question in the chat, I'll answer it next time we get to that. So let's see. All right, so that's everything as far as outputs go. So let's talk about config. So there was a good question earlier about config files, right? Or the config of this. Now, by default, Pulumi has its own convention for loading values from config. I'm already apologized, but I'll apologize again. They are in YAML files. Now, technically, we're using our programming languages, right, with the full power of whatever that language can normally do. So if you want to instead load these values from a JSON file or XML or CSV or external web service, that's an option. That is something you can do. However, you don't get the benefit that Pulumi has for automatically putting those config values into the backend. So remember when I pulled up the portal earlier, I was kind of scrolling around a couple of different tabs, but one of those tabs was the config. And I'll show you the config YAML in a second, but it's really just a copy paste of the values. And in a couple of cases, an actual secret. So we'll create an encrypted value and load that into config. Now, because Pulumi is keeping track of this config, it also does it per stack. So remember earlier, I mentioned stack is something that I like to think of like an environment, and I assume most people probably think of it like that. So everything that we've done so far has been the dev stack, so dev environment. If I want to then create a set of resources for my QA environment, the only thing I'm going to change is a copy paste of this config file and then change whatever values that I want. And then same with whatever other environments you want. You want some kind of integration environment, production environment, whatever you want there. When you're loading your config values in code, there's 3 different things that you can do. There's a require, so this will throw an exception if that value is not there. You can just get the value as its data type, and because we're not saying require it, it might be null. So throw an exception, or if it is null, handle it however you want to handle it with your code. And the last one is require object. So you can load complex objects from your YAML. One thing to note, this require object does require that there's a something of my object there. However, if it's if it's missing properties, maybe a property or two are null, that is something that you have to deal with. So you have to handle loading that, or throw an exception if it's missing the value. So that's on you. Now let's actually look at what this looks like in code. All right. All right. So I'm going to go ahead and open the pulumi.dev.yaml file. So this is the config that I was talking about earlier. So there are a couple of things that kind of take a second to really understand. So let me go ahead and zoom in a little bit. So first off, like I said, it's YAML. So you have your config at the top. It's all white spaced. Notice that there are a couple that are different as far as what they call namespace. So we have Azure-native : location and Pulumi : template. So and then the third namespace is the one-tug-example. So one-tug-example is the name of this project that I created. All of the config, this stuff all works off of what they call namespacing. I'm sure there's a lot of documentation on it. I've kind of just fumbled my way through. Basically, any setting that you want to set, just give it the name of your project, a colon, and then the name of the actual project, or the name of the value itself. The Azure native, so these are ones, essentially they're defaults. So because I've set the Azure location to East US, unless I say otherwise, every location, every resource that I create is going to use that default location. So there is actually a there's actually a location property here, but I'm not setting it because it's using the one directly from here, which actually means I don't need to set the location here, but I'm just going to leave that there for now. And here's an example of a complex object that's being loaded. So my app-service, and so there are 4 properties in here: my service plan, my web app, et cetera, et cetera. One thing to kind of note when loading from an object, you don't have a lot of customization. So notice this AAD tenant ID or resource group name, I use dashes, but when it came down to these properties, I just went with the default way that C# usually likes properties to be made. And the reason for that is because I think that for something like storage account name or resource group name, it should use the conventions that the tool likes using. But those conventions, using dashes in a property name, don't work with C#. So that's why I did that here. Now let's look at how this code is actually loaded, or how the config is loaded. So first you create a new Pulumi config object, and this is just the object that knows how to read from config. So I have a method down here for loading global config, and that's just for loading, my location, resource group name, etc., all of those things. And then I am just choosing to put those into some new object that I'm going to pass around. So just keeping that really simple for myself. But then separately, we have this require object that we're doing right here. So again, this is a complex object. Now I'm loading this as a DTO. So remember earlier when I had mentioned that even though you're requiring the object to exist, if one of those properties isn't set, it's on you to go ahead and check that. That's something that I have done for this example. So I'm going to go to my AppService config DTO. This is a pattern that I like for loading things that can be null. So remember earlier I had mentioned that I like using nullable references and treating warnings as errors. So this is a pattern that I've started working with because of that. So I have what I call my DTO, my data transfer object, and everything can be null. And then there's some kind of method to just validate that the object is good. We're going to validate all the properties, and assuming everything's good, we'll return an instance of something else. In this case, I'm using a record to just return all of that. So this is me doing that extra step of validating each of the properties. And so if I go back to how this is actually used, so we're requiring an object of my DTO, and then we're running our custom code to validate the individual properties. But now we know that, hey, it's a record, so it's immutable, and those properties are all valid. They're all at least not a null or empty string. So that's loading config. All right. Any questions? I don't see any questions in the chat. Okay. So let's talk about secrets. So there are actually two different places for secrets to exist. You have secrets in your config, which are loaded, and I'll show you an example in a minute. And then there are secret outputs, which we've actually kind of already seen that. So let's talk about them separately. So a secret in config is something that, again, it's an encrypted value. It is per stack, and it is unencrypted when you want to use it. So essentially, when you say Pulumi up, because you're going to run Pulumi itself, that decrypts the value, and then, well, now it's in memory, so it can be used for anything. So, excuse me, sorry. Sorry, give me 1 second. Okay, sorry about that. So, where was I? Talking about decrypting secrets. So, anyone who has access to the repo to using Pulumi, you have the ability to decrypt it, right? Because as long as you're added as a team member to that Pulumi project, you can get the value. So this is one of those things that it depends on how sensitive that information is. If it's something that you are willing to share freely within the team, then yeah, it's a good place to put that there. If it's not, if it's something that needs to be, more explicitly created in some other way, then you're kind of on your own to figure something out. So, if you're using Azure, I guess Azure Key Vault is a good place to do that. But again, because these are per stack, the way that I would do this is, let's say that I have some password that's used for let's say I have some password for connecting to Azure Key Vault, and I want to just connect to it and grab some values. So in a dev environment, yeah, you kind of don't care, right? That's not real data. So you're still going to set it as a secret, but yeah, just only share that with the people who have access to the dev stack. And you can lock down the production stack, so the encrypted value is only accessible to the 2, 3, 7 people that have access to production. So there are ways to work with that. So let's actually look at an example of what that looks like. So I don't already have a secret here, but I can go ahead and create one. So there is a command line value for that. So I'm going to go ahead and, I should have written this down. Pulumi config help. Let's see, Pulumi config. Sorry, I knew there was going to be something that I would forget. So -s is going to be on my dev stack. And I believe it is, let's see, so it's one tug dash example. Sorry, I need to copy paste this. Let me just make sure I got this right. One tug example colon my secret, and the value is going to be ABC123. And we need the flag to say that this is a secret. So I really hope that I got that right. No, that is not the correct way. Hey, there we go. So that one worked. I just was missing these sets. So this is how I add an encrypted value. Now, if I go back to my config, notice that it added this encrypted secret value. So this is the ABC123 that you just saw me set. And I can go ahead and if I go and run Pulumi up again, it's not going to create anything because we haven't made any code changes. The only difference is that now we have that secret. And so once this is done running in a second, we will see that that secret show up in our portal. So let me pull that portal up over here and go to our stack. And on my other screen, I see that it is finished running. So we should see in my configuration, yep, my secret. There we go. So one tug dash example, my secret. So that's a config value secret. Now we've already talked about outputs. And so you can have a secret as an output. And we've actually already seen a few examples of those. So you saw one property called random password. You saw another one that was a connection string to some Azure storage. So those are marked as a secret in your code. And so let's look at an example of that. So we'll only look at one of these. So we'll see primary storage key. So where am I setting that? Okay, so this actually has a couple of things to understand what's going on with this line. So resource group.name and storage account.name, these are both outputs. And so the apply method is saying, all right, let's take these outputs, and once they're created, then we can call this method, the create secret method. Now, create secret method also separately calls this get storage account primary key. So this method right here is calling a method to essentially load the primary key to connect to that. So don't have to know exactly how this works, why it's doing what it's doing, but the important thing is that the output.createSecret is what's being called. So this is Pulumi keeping track of the fact that this is an output and it is something that needs to be encrypted. So that's essentially how that's going. You know what? Let's show the other example of random password. This one's probably a little bit easier. We create a random password, and then based off of the result, the output string that comes out of that, we're going to call the output.createSecret using apply. So this, again, is just taking this output, setting it as a secret. Now, one thing to note is that you can actually view these secrets in the CLI. And so let me bring that up. Now, this is a command that I wrote down. So I will go ahead and run this. So Pulumi stack output show secrets. Now, again, I'm only able to see these secrets because I'm added onto the team. If I were not able to view the values of this dev stack, then no, I wouldn't be able to, well, I wouldn't be able to access Pulumi itself because these decrypted values are getting them directly from the backend. So it's had to send a request to Pulumi's backend and then get the value. So these are these secret values. Feel free to copy paste those. I will be deleting all of these resources at the end of this talk. All right. So what's next? All right. Let's talk about random values. Now there was a question earlier about keeping things idempotent, and that actually feeds directly into this kind of question. So normally, when you think like, hey, I need to make a password that's going to be used by a couple of resources, and I need to make it once and then share that. Well, you can't just go and make your own function that creates a 100-character password and then you store it, because every time you run your code again, it's going to make a new 100-character password. And if it made the same 100-character password every time, that would be a bug and a very, very big problem. So how would Pulumi keep track of that? Well, the idea is that everything is a resource. Pulumi keeps track of all of this stuff as a resource, as a thing that it keeps track of in its backend. So in this example of what we're looking at right here, this is the name of the resource, API app Microsoft Provider Secret. And so if this doesn't already exist in the backend, then it's going to go ahead and run whatever code it needs to actually generate a 100-character password, assuming that this resource already does exist, meaning that this is the second, third, 100th time that you've run this code, this Pulumi script. It's not going to create it because it already has created it. So what about the case where something happens, that password got leaked, you need to roll it. It's time. Something happened. Well, there is a way to do that within code. Let me end the slideshow, and I'll show you. So this is that code that we were just looking at in the screen. So if we look at the properties of this, there's a good handful of options for things if you want to go ahead and customize this. But keepers, this is the thing that you need to change to say this is something that needs to be regenerated. And this is specific to this random password thing. But essentially what you do is you go ahead and you say, and sorry, I forget how this works, but let's see, input map. I believe I can just make a new dictionary. String. one. Oh, no, I think I need to wrap that again. All right, this is another thing I should have written down. My fault there. Nope. All right, one. Well, this is embarrassing. Something I should have gotten a little bit better. Oh, I forget how this works. Input map, mutable dictionary, string. All right. This. Okay. Hey, there we go. All right, I was close. So every time that you need to roll your password, you essentially just need to make some new entry into this. So let's say the time has come, the password got leaked. You need to roll the password again. Well, just come here, copy paste it, and say 2 or whatever you want. I mean, if you want to use this as like a name for something or like an incident number, whatever it is that you want, just put something into this object. And that's how it knows to keep track. Basically, what you're doing here is you're saying this resource, this random pass resource, has changed enough that the old thing needs to be removed and replaced with this new thing. So that's what runs it again. Now, there are a couple of resources that exist that kind of follow this pattern of this keeper's property. So something to keep in mind. The syntax, I guess, is something to look at every time, every time that you need to. Unless you're presenting on it, then it's probably the syntax of something you should have written down earlier. All right, so the rest of the presentation is actually pretty quick. It's just a couple of slides of just one-off pieces of info for things that might have miscellaneous questions. Before we do that, does anyone have any questions of anything that we've already covered? Let's see. So there's one question. Are there any compiler warnings or similar to warn you that something should be treated as a secret? For example, a storage account key or something ending in password. I don't think so. I'm pretty sure that there isn't anything built in for that. If there is, that would be awesome. You know what? Let's find out. Let's add a new one. And I'm going to call this storage password. And I'll call this my storage password. So if I go ahead and build this, build succeeded. Let me go ahead and Pulumi up and see if it does anything. So I would assume that it would complain about that before actually running. Oh, hey, all right. What is it complaining about now? Oh, I think that's probably from the code change. Maybe I did this wrong. So let's go back and try it one more time. Let's delete the change that I'm not 100% sure about how that actually works. All right, so this is running, and yep, completely unchanged. So no, I'm guessing that there isn't anything already built in for that, but that would be really cool and useful. All right, any other questions?
I do have a small question. So these are kind of Azure objects, and I'm kind of familiar with that sort of thing. And I do wonder, is there any crossover between AWS or GCP objects? I mean, is there any kind of like? I imagine each of those is kind of mapped to its own completely separate set of objects. There's no real sort of corollary relationships there. Does that question even make sense?
No, yeah. So I know exactly what you're talking about. So let's say, for example, in Azure we have a storage account and blob storage. AWS has S3 buckets, right? So I think you're asking, is there some way to just say I want a storage thing in this target cloud resource? Unfortunately, no. There can be something. So if someone wants to make a like a public package, like a NuGet package that does something like that, that's an option. But for something that's specific to that cloud environment, as far as I know, Pulumi is not trying to make any changes or Pulumi is not trying to make any resources for something like that. So now there are some utility resources, like this random thing. Sure, that's something that can be shared amongst different clouds, but no, for something like resource group or app service plan, that is still going to be specific to that cloud provider.
Sure, makes sense. Just kind of curious. Thank you.
Yeah, no problem. All right. Yeah.
Could you discuss how Pulumi fits in the context of CI/CD and maybe others? Yeah, CI/CD using one of the popular ones, like repositories for Docker.
Yeah, definitely. So, okay, so if you want to incorporate using a tool like Pulumi into one of your CI/CD pipelines, Azure DevOps is one I'm very familiar with, GitHub Actions, and then other non-Microsoft related ones I'm sure exist, right? I guess, I don't know. But on their website, they actually have a pretty good tutorial for showing how to go ahead and set that up. One of the benefits of running a tool like this as part of your pipeline is that now changes to your infrastructure are pull requests. So if you all of a sudden are working on some project and you realize like, hey, you know what, we have some Azure storage over here, but we want to use a queue for some processing. Well, let's just add that to this, this my stack over here, make it a pull request, and as soon as that runs, great, that works. Now you are still using your CI/CD tool to call into this Pulumi script, for lack of a better word. So, for example, if you're using something like GitHub Actions, you're still using their YAML. Now there is actually sort of a way around that. I have a small slide later on where I'll kind of mention that. But the short answer is Pulumi has a tool or something that they call the automation API. And so that's if you want to create your own code to call Pulumi instead of running in this CLI that we've been running this entire time. So it's essentially a NuGet that you reference. That's kind of, if you want to think of it as that way, that's kind of how you would call it there. But yeah, if you want to use this within a CI/CD tool, you can definitely do that. I've done that for some GitHub Actions. Actually, something that little off topic, but it was really fun. In my config, because of the way that I've set up my infrastructure, I've set up with Azure Active Directory access to certain applications. And so if I want to add or remove someone to give them or remove their access to this internal application, all you have to do is add or remove them from config. So it's just adding their Azure Active Directory ID. And so that so then all of a sudden adding or removing just becomes a pull request to whatever application that they should have or should no longer have access to. So I hope that answered your question.
Yeah, I think so. So basically, Pulumi is completely independent of GitHub. It can be used by GitHub, but so a related question might be, can Pulumi be used to deploy my applications through Docker and Docker Hub?
So I'm not 100% sure on that. If we actually go back to the registry, I believe, nope, that's not how you spell Docker. So there is a Docker package. I've never used it, so I don't know what it can or cannot do. But yeah, if you want to deploy images to a Docker registry or something, I would assume that this is what you use. So I've never tried working with the example that you've mentioned, but I assume that there is a way to do that. Yeah.
Thank you.
Yeah, cool. All right. Any other questions? Okay. All right.
Actually,
so,
if you don't mind, I actually have something real quick. What you've laid out so far has made total sense. And the kind of the workflow you've shown, and you mentioned the automation API. The workflow so far is very much you write a config file, and you write some code, and then you from the command line you launch it. Or you could, you know,
Mhm.
in a CI/CD pipeline, say, hey, we have all those things in a repo somewhere, and the pipeline does those things. But that's still a very manual process. It's. I just actually read something great today about this idea of automated versus autonomous, and this idea that an automated process is you press a button and some steps happen, versus autonomous is an event happens and then some steps happen. My interest in Pulumi is very much on how it can be integrated into a more autonomous system. So, and I'm glad you mentioned the automation API, because that's kind of where my interest is this idea that because Pulumi works really within a full programming language, and has those deep hooks into the logic and just the power of a full programming language. It feels like that's where the real strength of Pulumi would be, because I don't really see the value of using Pulumi as just a kind of a more complex infrastructure as code type approach, where you have a configuration file and you just have some extra steps in the middle. You have to write some code for that configuration file to get executed by, or to get processed by an executable to spin up some infrastructure. Where and I don't know what your experience is using the automation API. But kind of where are sort of those rough edges with Pulumi of using Pulumi kind of more like a backend engine, that an event happens, use that automation API, it tells Pulumi, hey, here's some metadata, do this thing, without requiring that human intervention in the middle.
So I think a lot of the autonomous stuff is really just how automated you've made everything else. So for example, something that I've personally set up on one of my personal projects with Pulumi and GitHub Actions is when I merge a pull request, a GitHub action kicks off. And so that action then runs through, its set of steps of stuff. But one of those steps is running Pulumi. And so it itself is then running Pulumi to create whatever resources that I want to create for that environment. So in my example, or the app that I'm using, so let's say it's by default, when I make that pull request, or when I merge that pull request, the dev environment automatically gets updated, and then things get deployed to it and all of that kind of stuff. I'm not too sure how different that might be, kind of along the lines of what you're asking, to be honest, because I personally feel like that's very automated, right? This is a manual thing that you still have to do, but I mean, everything in some way ends up being some sort of manual step at some point down the line, right? It's just how many things are automated along the way. So, and the automation API, like I said, it's really simple. The automation API is just a way in code for you to call Pulumi somewhere else, and that's kind of it. I used it because the GitHub action that I use, and you'll kind of see that I'm trying to avoid YAML as much as possible. So my GitHub action build calls a cake script. So it's if you've never heard of cake, it's supposed to be like a C# make script. So it's just a script for doing builds, but written in C#. And so that does everything. It makes my build and it uploads artifacts and stuff. But it'll also, using C#, it uses the Pulumi automation API to call the Pulumi script that I've created, and then there's everything out there. So I'm not sure if that answered your question.
Yeah. So in the kind of in the use case we're looking at in my organization, is that we have over a dozen developer teams, and a quote I just heard today was, what we're trying to do is we're trying to take sort of a platform approach, versus a where we have a platform team, they're providing this platform, the developers then consume. So this idea, and the quote I heard was, if you have 1,000 developers, you don't want 1,000 Kubernetes experts. This idea that we don't want each of our developers to have to understand what the infrastructure is, what the infrastructure should look like, how the infrastructure works. We don't need, like I said, we have over, a dozen developer teams, 10 developers per team. I mean, a couple hundred people. we don't want that many Azure experts in our organization. We want our developers to be able to say, hey, I understand my application. I know the important metadata about my application. I want to put some metadata file, YAML, JSON, whatever, in my repo with my application. And then we have some, in our Azure DevOps pipeline, we have a custom task in there or something, a PowerShell task, whatever, that just says, hey, deploy. And in there, it says, hey, I'm going to look at this metadata file that the developer has said, we know what this is, whether it has sensitive information, it's an API that deals with sensitive information, credit card, health information, whatever, whether it needs to be, it's an internal application, whether it's an external facing application, all of those things. The developers know that. They're the ones who are the experts in that information. So they provide that. And then when it hits that task and the Azure DevOps pipeline, then that kicks off a thing says, let me read that information. Let me ingest that, parse it, and say, I know the infrastructure you need to have to run that application. And so we're really trying to get our devs away from having, currently they're writing Terraform files. We don't want our devs to write Terraform files because, again, all infrastructure is in a state of flux. Standards change, naming conventions change. We don't want to constantly have to make our devs like operations engineers light. We just want them to focus writing their code. So my interest in Pulumi is because it hooks so well into a full programming language. You're not trying to write logic in a YAML file because writing logic in a YAML file is terrible. So what we're trying to do is write logic in a real programming language. Up to now, we've just been trying to brute force it through PowerShell. But if there's a better way of doing that, we want to leverage that. So we want the devs to be able to take that metadata file, put it in in their repo. They run their code, they run their pipeline, which reads the repo, reads those things, and then does a bunch of stuff without anybody except for maybe the platform engineers who know how to write that Pulumi code that talks to the infrastructure. They're the only ones who need to know how that all works. The devs just need kind of that metadata. And that's really kind of the use case we're looking for.
Yeah. So, there was a lot there. On one hand, that does feel like a philosophical debate that I'm just going to step away from. Like, should the developers be writing the infrastructure? On one hand, that's an extra thing that they have to do. They're not really managing it, but on the other hand, they're making the application, so they should make the application work with the infrastructure that they know that it should work with. So that there's a lot there, but you can, for the example that you've mentioned about, you want something with custom logic. You could use Pulumi for something like that as that middle layer, where you have something that reads whatever this file is, this metadata file is, and then it calls out to whatever thing it needs to call out to. However, you're still going to end up writing, your Pulumi code in some way like this. Now, you can get a little bit more. You can get a little bit more specific in value. So, like, what I mean by, like, let's say one application, the metadata says that, hey, I need this service and this service. You can get a little more dynamic in that, so that way you can do that. The hard part is with how Pulumi keeps track of the state of everything. Remember, all of this stuff that we're creating is stored in the backend, and that is per stack. So the thing that you're describing does feel like it's very different from how Pulumi has everything built for how it's supposed to work. So I feel like at times you're probably going to end up fighting the tool. And that might also be similar to other tools too. Like I'm really not familiar with Terraform at all. So I don't know how that keeps track of its backend state. I know that it also does keep track of the state somewhere in like a file somewhere, but I'm not too sure. So I don't really know too much, but I would definitely recommend looking more into the automation API for that.
But in that use case, could it be that you got just a few experts in Pulumi that write this special program that reads that special configuration file that the rest of the developers create, and then this program just reads those configuration files, and the logic in that custom program, it knows what to do with that configuration. So, for example, if the configuration said, and it's just a random example, but I need a .NET service, then that's all the developers specifying the configuration. But this custom program that was written by the experts in Pulumi will read the configuration and the code to create that service, the Azure function or that web service in Azure. It's there So I guess it would be like a custom program sitting between the developer's configuration file and actual Pulumi. So that middle translator between the two.
So I think if you go that route, what you end up doing is you lose some of the stuff that Pulumi does for you. Like, for example, it's not really good. I mean, it will try at that point to keep track of all of the resources that it creates. But remember, all of the resources that it creates are part of this stack. And so, I mean, there are a handful of different ways that you can do this. Maybe you'll end up with one stack and just a bunch of if statements. If the metadata wants this, then create this resource, and you'll end up with something like that. But then again, it also does this per stack. We've only looked at an example with one stack, with the dev stack, but I really think that if that's the route that you're going to go, you're probably better off, maybe using something else, maybe PowerShell scripts or something. I mean, you can do all of this stuff in C# if you want to. You can call out to the Azure command line or something like that. That's an option. But I mean, I don't think for that use case that Pulumi would work well, because I do think with it wanting to keep track of all of the resources that it creates, that you're going to end up fighting it. I think that's probably what's going to happen. All right. So we're probably out of time. I do have a few more slides of miscellaneous things. If you want, I can rush through them. There's no other code examples for that. I guess we can. I don't know if we want to take a vote, or I don't know if you just want to yank me off the stage here. I'm good either way. I went over the important bits.
I think take your time, take as much time as you want. So certainly go through. If you have more slides, let's see them. Okay, cool. All right. So like I said, the rest of these are just kind of one-off things, just something to keep in mind when using Pulumi. So
okay, I have a question.
Yeah. Mm-hmm.
In terms of keeping up to date with latest releases and platforms like Azure and AWS, how sometimes you have preview features and other items. How good is Pulumi with that?
They're pretty good. So a lot of the stuff with the big cloud providers, from something that they had said once on, I don't know, Twitter or a video call or something that they've done once, they made it seem like a lot of that stuff is just is automated now. So Azure publishes something, and then they're able to get that and then just generate all of this code, and then they rev whatever packages, like NuGet packages or npm or whatever is needed for working with that. So they're actually really good. A couple months ago, I forget what it's called, the Azure Container Apps service was announced in preview, and that day I saw Pulumi posting something saying that, yep, we already have packages ready for you to go ahead and start using that in preview. So although they might have been working with some people in Azure ahead of time, I wasn't sure, because they also made it seem like they were ready, because they had an example already up very quickly. So, but yeah, normally they're really good about it. Mm-hmm. All right. Cool. So back to the slides. So one of the things that's going to pop up with any kind of managing cloud resources is referencing something that already exists. There are two scenarios. So this first scenario is, let's say that you have a your team is managing, X infrastructure. Someone else over here on, maybe you're doing some kind of microservices, something or other. Some other team, they have something. You just need to know a couple of values from those resources. For example, their host name, right? Like if your application wants to know how to point to that endpoint, then if you can just automatically get it from from that resource, that's great. So Pulumi has a couple of things called getter function, or Pulumi has a couple of getter functions. So that's their name, called them getter functions. So these are read-only functions that will query that cloud resource, try to get the values for it, and then you can reference them. So there's a code example down here. This is an AWS code resource, but it'll go ahead and try to read for some security group, whatever that is, and then get the values. So then you can start referencing all of those values as outputs. Now, another scenario where you want to reference existing infrastructure is something where someone has already gone and created this, but you want to include that in your Pulumi stack, in this script that you use to manage your infrastructure. So there is a command, as you can see right here, Pulumi import, and then I'm not 100% sure on what all of this means. Oh, sorry, it looks like there's 3 things there. Again, I just copy pasted a lot of this stuff from Pulumi's website, so that's why all of these are AWS examples. But this will import anything that it needs to know about into the backend. So these 2 images right here are showing that the first thing it does is Pulumi will grab those values and put them into its backend so that it knows that those resources exist. Then it will also output some code that you can then cut and paste into your solution. So that way you can now, all of a sudden, this thing that already exists, we bring it into the fold and we know how it works, and you can start modifying it or controlling it through your code. All right, next up, really quickly, logging. There's logging in Pulumi. Console write line works. The only reason that I put this out here is because I was using console write line for a long time, and then as I was doing research for these slides, I found examples of logging info. So I think the big benefit is changing the color of the text on the screen. So, hey. All right, this is just cool. Runtime debugging of your resources. So again, you're using the full power of your programming language. So you can debug this. The way that I usually debug my Pulumi apps is by typing in debugger.launch. So hey, let me go ahead, debugger.launch. Let me add my breakpoint. Oh, sorry, that returns something. And then I'm going to go over here, type Pulumi up, and then this is going to go ahead and run it. And Visual Studio is going to give a little pop-up to once it hits this line. So it's doing a build. Hey, there we go. So let me use this instance of Visual Studio that I already have. Yeah, so there we go. So now we're debugging. Now there is some mixed benefit of this. On one hand, you have the debugger attached, so you can see what values it has. But remember, you're still not able to view the values of outputs. So for example, if I mouse over this global config, I can see the values of these properties that I've set from config. But my resource group, well, that's all outputs. So I'm not really getting values from there. So if you just need to debug, the individual steps, this is very useful. All right. And oh, sorry, my dog just ran in here. All righty. So I've already talked a little bit about the automation API, and I've kind of already said everything about it. Sorry, my dog really wants me to go out. Hey, no, I can't go. I can't go outside. Sorry. So the idea behind the automation API is instead of calling directly to the CLI like we're doing over here, you can include that into your code and just call that directly. I don't have a code sample, but if you look it up online, it's actually really simple. It's like 1 or 2 lines. You're loading the stack, and then you're choosing to Pulumi up or to run it or destroy it or whatever you're doing. It's just an easier way to call into it from your code. If you didn't have the automation API, then in your code you would just be calling out to a command line program. That's essentially the change between those. All right, and then next up, we've already seen this image. I just wanted to bring it up one more time before we go to the next slide because I want to talk again just as a reminder of how this works. So you have your code that you type, and then that goes through some sort of binding layer, which then goes to this underlying thing that is the thing actually doing the work. These Go modules that will actually talk to the back end and then figure out what should we be creating or destroying. And then it'll actually run everything. And so the reason that I wanted to pull that out is because, oops, I hit escape too many times. The reason I wanted to point that out is because if all of the real work is being done by something else and it's just the code that you're using to call into it, why can't we automate the stuff calling into that? And so that is why Pulumi has gone a step further and created packages or Pulumi packages. And so the idea is, let's say that you want to make some sort of custom Pulumi package for working with just something that you want to work with, right? We saw an example of a ton of packages that are working with different cloud providers, right? We saw Cloudflare as an example, Auth0, Akamai, all of those. So since the real work is being done by something else, what if you write your code in your language of choice? So for me, it would be C#, but then you run a command and it generates the package for everything else. So I write my C# code, I generate a NuGet package, an NPM package, and then Go and Python and those other ones. I don't know the names for those, but you can do that. So there's some tooling for that. There is a little bit of work that you have to do. You have to create a manifest file and create a couple things like descriptions, but that's an option. That's really cool, right? So now you can write your code in one language and automatically support everything else. I've never used it, so I don't know too much about it, but just wanted to throw that out there as something that's really cool. All right, and then this is my final slide. There are converters, so if you're using Azure ARM templates or Terraform scripts or something like that right now, they do have some stuff on their website to transform what you have into Pulumi. So you can go ahead and choose an example. So if I go ahead and I click on Terraform over here and bring my browser over here, convert the Terraform. So this is an example. So if you want to go ahead and copy paste your Terraform stuff in here, click convert, and then whichever language. So if you want to convert this to C#, this is the output that it would go and create for you. So again, this is something that you should probably not use assuming that it's 100% correct. Use it as a starting guide, but that is something that exists. That's an option. All right, and that's it. That's the last of my slides. So again, everything that we've talked about for this presentation is on my GitHub repo, github.com/programRel/presentations-2022. And if you want to find me online anywhere, just search ProgrammRL. I tried to take that everywhere. Anything semi-professional, at least. All right. So any questions? Anything else? I feel a little bad. I think we went way over time than I'm used to for hanging out on these.
No, that's quite okay. That's why I scheduled these meetings for 2 hours.
All right.
This is not a conference talk, so there are no restrictions. There are no speakers waiting behind you, so we're good.
All right, cool. Well, then in that case, one last thing. I am going to Pulumi destroy, and let's get rid of all of the resources that I've already created so that I no longer have to pay for them after this talk is over. All right, but cool. Yeah, so any questions, anything else anyone wants to mention before we close on up?
Nope, I guess not.
All right, cool. Oh. See someone chatting. Well, hey, thank you for having me here. Like I said, sorry I went a little over, but it's always fun to do these talks. Always fun to force myself to do more research and learn about things like the logging methods.
Yeah, that's how I learn things too. I give talks on them, so I go ahead and learn it because I don't want to be embarrassed at the talk. So.
Mm-hmm. Exactly.
I think we can stop recording now.